Okay, this is chapter 21, AP Physics N. Um, it's 21.1 to 21.4. Very easy. State the principle of conservation of charge. Basically, with electric charge, they treat it the same as energy. Okay, so the same formulas that apply to energy are just almost the exact same with charge. You're gonna see, as you can see, as we move on, you're gonna see they're very similar. Okay, state the principle of conservation of charge. The same way we used to have the principle of conservation of energy, same thing. What was the conservation of energy? In a closed system, if there's no external force acting, then energy is conserved, right? The total energy is the same. Same thing. In a closed system, the total sum of electric charge is constant. So the same thing, electric charge, you kind of see it as energy. Okay, consider three particles A, B, and C. Okay, I'm just gonna show you the answer and you'll figure it out yourself because the grade sixes know how to do this question. Okay. Question 3. What are the particles that constitute an atom and how are they charged? Okay, again, this is very easy. Atoms, you guys know, have neutrons, protons, and electrons. What are the charges? You guys know neutrons don't have any charge. Protons are positive, electrons are negative. There's nothing for me to explain here. If you remember, any atom, X, it has its nucleus, okay, that has protons and neutrons, okay, and then electrons outside. Okay, this is the simple model of an atom. Okay, the total charge of the system S here is -5, so it's a closed system S, and they said 3 electrons are transferred from A to B. What is the total charge? So what is the total charge? If it's a closed system, then obviously the total charge will not change, right? It will not change. So it's still gonna remain as -5. If you take a look at the answer. So according to the principle of conservation of charge, the sum is always constant since it's a closed system, right? The system S, it's closed. Did they say there's any external force? No, we just said خلاص. We transferred the charges here from here to here, but in total, it should be the same. Okay. Define conductors and insulators. Give an example of each. Is very easy. Okay, conductors are obviously materials that allow electricity to move or any charges to move through them, while insulators are materials that do not. And this is straightforward. These are examples of conductors. All metals are conductors, and these are some insulators, mostly non-metals, right? Identify whether an attraction, repulsion, or interaction exists when the following objects are brought close to each other. Okay, 2 glass rods rubbed on silk. So the glass rods will both be positive and they will repel. Okay, I'll tell you the rule after I finish the question. 2 plastic rods rubbed on, for polythene is plastic, they will also repel. And a charged plastic rod and a charged glass rod, they will attract. Why? Okay, you might ask why. It's because glass, when rubbed on silk, or in general, he's not going to give you another example, but when glass is rubbed, it becomes positive. Okay, and plastic, otherwise known as polythene, is when rubbed on wool usually or fur, it becomes negative. So over here you have 2 positive charges, so they're going to repel. You have 2 negative charges here, so they're going to repel, and here you have a positive and a negative, so they will attract. Okay. So let's take a look. Where am I? Okay, yeah, the 2 glass rods will be positive. Okay, whatever. Okay, state Coulomb's law and give its mathematical expression. Wait, did we skip 7? Oh, yeah. A positively charged rod is brought near an uncharged metal ball that's connected to the ground. What is the induced charge on the ball? So if we have a positive charged rod, it's brought near an uncharged metal ball, right? So there's no charge here. Okay, and there's no charge. Okay, so when you have a positive charge a positively charged rod that goes near the ball, you guys know that when we say it's neutral or uncharged, it doesn't mean it has 0 protons, 0 electrons. No, it means that the number of positive charges is equal to the number of negative charges. Okay, so you have these positive and negative charges scattered around such that the number of positive charges is equal to the negative charge. But when you bring this positive rod near it, obviously this positive rod is gonna attract the negative side of the sphere. You can tell me how. I'm trying to find words. I don't know why I can't talk. This rod, isn't it positively charged? Of course it is, right? Since it's positive, what does positive attract? Positive will attract the negative particles, right? So the negative particles will come and move towards the side of the sphere facing the positively charged rod. So the induced charge on the ball will actually be negative. Okay, that's pretty much it. Let me just double check that. Okay, yeah. So an uncharged metal sphere has 3 electrons, whatever. When a positively charged rod is brought near it, the electrons will move closer to the positively rod, right? Um, Therefore, the induced charge is negative. Okay, I forgot to mention this. They are repelled and radiating to the ground. So in my example here, since it's connected to the ground, over here I have the positive rod, yeah? Okay, these negative charges come here, right? So this is connected to the ground. Since there's excess positive, anytime you have excess charges and it's connected to the ground, they will always leak. Remember, they get earthed. Okay? So if you see any example like this in the exam maybe he gets it for you, negative rod, you'll say the induced charge on the ball is what? Positive. Okay? So it's always the opposite. Question 8. State Coulomb's law and give its mathematical expression. Coulomb's law, it's literally this, and I think you should memorize this, okay? The magnitude of the electric force between 2 points is directly proportional, okay, to the product of the charges and is inversely proportional to the square of the distance between them. If he wants to get this in an exam, I'm gonna tell it's probably gonna be like, what is true, okay, about Coulomb's law, okay? And it's probably going to say that the electric force is directly proportional to the square of the distances. This would be false. So you don't choose this. Why? Because it's not directly proportional to the square of the distance. It's inversely proportional. How do you know if it's inversely proportional, directly proportional? Some people, they still struggle with this. If you know this formula, خلاص, you know everything. Okay? F is equal to K Q1 Q2 over R square. Okay? If one is up and the other one's up, يعني they're directly proportional. So F is directly proportional to Q1 and it's directly proportional to Q2. But since R squared is down, you say it's directly proportional to 1 over R squared. Okay? And when we say 1 over R squared, it's the same as saying it's inversely proportional to R squared. So F is inversely proportional to R squared. Okay? So these 3, you need to memorize them. Anna, for me, I don't memorize any of this stuff. It's very stupid. I just remember the formula. When you know the formula, you know what's directly proportional to what. If they're both up, then of course they're directly proportional. If one is down and the other is up, then they're inversely proportional. Okay? So that's where this answer came from. Okay? Anyways. So what is Coulomb's law? F is equal to K Q1 Q2 over R squared. And if it tells you to select all that apply, you say the electric force is directly proportional to the product of the charges, Q1, Q2, right? And it's inversely proportional to the square of the distance between. Okay, 2-point charges Q1 equals -3 nanocoulomb, and Q2 equals +5 nanocoulomb are separated by a distance of 2 centimeters. Find the magnitude of the electric force that Q1 exerts on Q2. I need to state something, that K is Coulomb's constant and it's equal to 9 times 10 to the power of 9. Okay, you need to know this. Okay, type. So over here, what is the electric force? Very easy. K, which is 9 times 10 to the power of 9, times Q1 times Q2. What's Q1? It's -3. And Q2 is 5 over R squared. So the distance, 2 centimeters. Remember, the distance has to be in meters. So it's going to be 0.02 square. Okay, let me just check if this is correct. Yes. Oh, I forgot to multiply by 10 to the power of -9. This is nanocoulomb. So the unit for nano, by the way, in case you see these, obviously milli is times 10 to the power of -3. Micro is times 10 to the power of -6. Nano is times 10 to the power of -9. And pico, which is denoted by this, is times 10 to the power of -12. Okay, if you see these. So over here, it's -3, it should be times 10 to the power of -9. Or times 5 times 10 to the power of -9. Let's see, is this what they did? Yes, they did, and they get this answer. It should be, let me just make sure. Yes, it is. Okay. Question 10. 3 charges lie along the x-axis as shown in the diagram below. The positive charge Q1 is 4 microcoulombs, is at x equals 4 meters. And the positive charge Q2, which is 8 microcoulombs, is at the origin. So Q2 is over here at the origin. A negative charge Q3 is placed on the x-axis such that the resultant force on it is 0, what is the x-coordinate of Q3? So I'm gonna take this into open board just so, what's this? I'm gonna take this into open board so that I give you some space. I need some space. Okay, so the first thing I want to write down is the given. Okay, so Q2 is 8 plus 8. Okay, right? And Q1 is plus 4. Okay, we know that Q3 is negative. Let's just say negative x. Okay, no, let's just say negative. Okay, type. So this is plus 4 microcoulombs and this is plus 8 microcoulombs. So the first thing you need to understand is in any point system, if you have two charges, there will always be a force, let's say Q1 and Q2, there will always be a force that Q1 exerts on the other charge Q2. Either if this is positive and this is negative, then it will be an attractive force. So F12 will be an attractive force, right? But if they were both positive مثلا, then they would be repelling, right? So F12 would be to the left. You see? Sorry, no, F12 would be to the right. Yeah. Okay, it will be to the right. But that's not my point. My point is just to show you, any two charges will always exert a force on each other. So over here, they said that the resultant force on Q3 is 0. So similarly to how in mechanics we would evaluate all the forces going on, same thing, you're working with forces, So let's take a look. What are the forces here? Since this is positive and this is negative, what is the force exerted on Q3 here? It would be a force that pulls it to Q2, right? Since Q2 is attracting Q3, they're attracting each other, right? So we can say F23 is to the left, and just so we can kind of understand. Okay, and you also have a force that attracts it to Q1, right? F13 is to the right. It's getting pulled to Q1, right? Why? Because this is positive, this is negative, and this is negative and positive. So it's trying to be attracted to these two. So what does this mean? We know that the resultant force is 0, so sigma fx is equal to 0, right? So what does that mean? That means this force here is equal to this force here, right? So F23 is equal to F13. And using Coulomb's law, we can figure out what these forces are. Remember, F is equal to K Q1 Q2 over R squared. So let's see. F23. F in this case is equal to K. Q1, what's Q1? Q1 is 8 microcoulombs, right? So 8 times 10 to the negative 6. Q2 is, we're just going to say Q3. We don't know what it is. The second charge, okay? Over R squared is the distance between 2 and 3, right? Squared. We know that this is equal to F13, so this is equal to K. Q1, either of these charges, let's just take Q1 over here, which is how much? It's 4 microcoulombs, so 4 times 10 to the negative 6, times the other charge, which again is Q3, we don't know what it is, over the distance between them squared, so R between 3 and 1 squared. Okay, so we can cancel some things here. We can cancel this with this, cancel this with this. So also they're just trying to find the x-coordinate, they're trying to find the distance, so this is very convenient. We found over here that if you cross multiply, you can take 8, so R31 squared times 8 times 10 to the negative 6 is equal to R23 squared times 4 times 10 to the negative 6. Let's make it so that the r's are with each other. So you can say R31 squared over R23 squared is equal to 8 times 10 to the negative 6 over 4 times 10 to the negative 6, which is just R31 squared over R23 squared is equal to 2 when you divide these. So we're trying to find the x-coordinate of Q3. So we're just going to call this over here as x. We know that the full thing is 4 meters. Okay, so they said that it's in total Q1 is at 4 meters. So we can rewrite these in terms of x and 4 meters, right? So let's take a look at R from 3 till 1. From 3 till 1, isn't that the 4 meters minus what? No, wait. Yeah, sorry. R31 is 4 minus xy, because this distance here, from here to here, it's x, right? So Just erase. I put that on the side. I don't know. It confused me. Okay, so we know that Q3 is placed at x meters. We don't know where. Let's say it's at x. We know that the full thing is 4 meters, and we know this is what Q1 from Q3 to Q1. So this Q3 to Q1, we can rewrite it as 4 minus x. So 4 minus x squared over R23. What's R23? R from 2 until 3. How much is that? You're going from 0 to x, so it's x, right? So x squared is equal to 2. And we can thus solve for x. So you're going to get 2x squared is equal to 4 squared minus 8x plus x squared. I cross multiplied and I expanded this. Okay, so 2x squared is equal to expanding this a minus b squared is a squared minus 2ab plus b squared. So you're going to get 2x squared is equal to 16 minus 8x plus x squared. Okay, so you're going to get x squared plus 8x minus 16 is equal to 0, which is just, I think this is it's a perfect square. Is it a perfect square? I don't think so. 16. Okay, yeah. So I'm taking a look here. I did everything correct except over here. I don't know what happened. But when I divided, I don't know how I got R31 over R23. It should be upside down over here, right? So I divide by 4 over here and divide by 31 there. So it should be flipped upside down. Okay, so this should be like this. So 2, 3, 1, 3, and then over here 2, 3, and 1, 3. Okay, so this should be upside down. So x squared over 4 minus x squared is equal to 2. And then cross multiplying, you're gonna get 2 into 4 minus x squared is equal to x squared. So therefore 2 into 16 minus 8x plus x squared is equal to x squared. So 32 minus 16x plus 2x squared is equal to x squared. And then taking everything to the same side, you're gonna get x squared minus 16x plus 32 is equal to 0. This is minus 16x. Okay, so you're gonna get 12, 16 and 2. ما بعرف bro. 8, 4. I don't know. How do you factor this? X squared minus 16, 32. You get 8 plus 4 root 2. 8 minus 4 root 2. So you're gonna get x is equal to 8 plus 4 root 2 and 8 minus 4 root 2. I'm kind of concerned because it's not this. Did they get the same quadratic? Okay. Anyways, so you get these two. This is equal to, when you have two solutions for x, obviously not both of them will work because how is q in two positions at the same time, right? So we're gonna take a look over here. What is 8 plus 4 root 2? It's 13 point, let's approximate it, 13.65. Okay, and 8 minus 4 root 2 is 8 minus 4 root 2 is 2.34. Okay, so obviously we know that our lovely x coordinate has to be somewhere in between this 4 meters. So can it possibly be at 13.65? Obviously it cannot. So therefore, this is, you can say it's rejected. Okay, so therefore x is equal to 2.34 meters. Okay, so nothing too hard. You just equate both forces, cancel. You're gonna get a simple expression where you can solve. Maybe the only hard part is expressing the distance in terms of x. I would see where people get confused there. But other than that, it's just solving math. Yeah, that's pretty much it for this question. Okay, question 11. In a thundercloud, there may be an electric charge of 30 coulombs near the top and negative 30 near the bottom. These charges are separated by approximately 3 kilometers. Find the magnitude of electric force between them. Okay, obviously they gave you two charges, they gave you the distance between them, so you can just do K1, Q2, KQ1, Q2 over R squared. So very easy. But make sure you convert your distance to meters, right? So that's it, just apply the formula. Okay, question 12. Consider these 3-point charges located at the corners of the triangle as shown in the diagram below, where Q1 equals Q3 equals 3 mu coulombs and Q2 equals minus 8. So Q1 is 3 mu coulombs and Q3 is 3 mu coulombs and Q2 is negative 8 Mu, why am I saying mu? I mean micro. And A is equal to 0.12 meters. So they gave us this is 0.12 meters. Find the magnitude of the resultant force on QP. Okay, I forgot to mention that over here it's also 0.12 meters. I saw A and A. I didn't see this A up here. Okay, so basically you kind of have like a triangle over here. Okay, so 0.12, 0.12. Um, so obviously this angle over here will be 45 degrees, and this will be 45 degrees. If you just do shift tan opposite over adjacent, you're gonna get 45 degrees. Okay, so we have 45 degrees, 45 degrees. This will obviously also be 45 degrees as well. So we see what's going on. So right now, let's kind of, I'll just connect these like this. Okay, and we're gonna put 45 degrees over here. This is 3 microcoulombs. Okay, so what do we know here? We want to find the magnitude of the resultant force on Q3. So what are the forces acting on Q3? Always look at the charges beside it. On Q3, we have a negative and positive over here. So QT, the force of 2 on 3, and we have the force of 1 on 3, right? So 2 on 3 and 1 on 3. Okay, so force on 2 on 3. This is negative and this is positive. So this is attraction, right? So obviously this will be moving, the force will be like this, right? So it's going to be moving to the left, right? And then you have positive positive over here. So obviously they're going to be repelling. So 1 second. Okay, F13 is obviously going to be a repulsion force. It's going to be pushing it away. So it's going to be looking like this, right? So obviously we'd never write forces like this. We're just going to draw it. It always has to extend out. This is the same as this arrow. Is that, bro, are you okay? Are you okay? Yeah, bro. This arrow is the same as this arrow, right? It's the same force. Okay. Uh, anyways, so we have these two forces acting on our lovely object here. So we need to find F13 and F23. Find them and find the resultant force, just like you would find a resultant force in any like graph. It's the same thing. You're working with forces. You want to find the resultant force. You have to split into x components and y components, add, and then find the magnitude. Very simple. Okay, so what's the method? Let's first find F13. How do we find F13? F13 using Coulomb's law to find any force K, Q1, Q2 over R squared. What's K? It's 9 times 10 to the 9. Q1, between 1 and 3, 1 is 3 times 10 to the minus 6 times Q2, which is 3 times 10 to the, Q2, Q2 in this case is the third object, right? Right, so 3 times 10 to the minus 6 over R squared. What is the distance between Q1 and Q3? The distance between them is obviously 0.12 radical 2. Why? You can calculate it and find the hypotenuse of the triangle. 0.1 with, this is a triangle, right? Over here. 0.1 to 0.12, and you need the hypotenuse. Just 0.12 squared plus 0.12 squared, and then radical, you're gonna get this. Okay? Okay. Also, you can just find it out directly. If these two sides are equal in any triangle, that's right triangle, it is 8, this is 8, this will be a root 2. Always, it's a rule, yani. Okay, anyways, so you're gonna get that the distance between them is 0.12 root 2 over r squared, right? So it has to be squared. Okay, so if you do this, let's find how much the force is. 9 times 10, 9 times 3 times 10 minus 6 times 3 times 10 minus 6 over 0.12 root 2 square. Okay, you're gonna get 2.8125. So F13 is 2.8125, and as usual, it's in newtons, it's a force, right? Okay, how about F23? Let's find F23. Again, using the same formula. 9 times 10 to the 9. Our first charge is Q2. What's Q2? It's negative 8, right? So times negative 8. And remember, it has to be times 10 to the minus 6 because of the unit being used. Times the second charge, which is Q3, which is 3 microcoulombs, over the distance between them squared. The distance between them is 0.12. So 0.12 squared. So it's going to be, I'll just use this one because it's a bit faster. Negative 8. You're going to get negative 15. Which I feel like this is wrong for some reason. Let me double check. Okay, no, it's correct. It's correct. So we found F23, which is minus 15. We found F13, which is 2.8125. So we have our forces. One going like this, F13, and we have one going like this, F23. Can't you find the resultant knowing that this angle is 45 degrees? How do you know this angle is 45 degrees? If this is 45 degrees, then obviously this is also 45 degrees because these two lines are parallel, right? So 45 degrees, 45 degrees. Okay, so you know this angle is 45. You know that this F13 is 2.8125 newtons. And you know this F23 is negative 15 newtons. Obviously, we can easily find the resultant. How? Remember, we have to split them up into x components and y components. So this is the x component, F13x, and this is the y component, F13y, right? Vector symbols. And you also have F23y, and you have no, sorry, there's no y component for it. Why am I? There's no y component for F23 because it's on the x-axis, right? There's no x. The y component is the 0. It only has an x component. So let's find the x component of F13. How do we find it? It's just 2.8125 times cosine the angle. It's 45. This is the x component. And then the y component will be 2.8125 times sine 45. And this one is just an x component, so F23, it's equal to negative 15. And F23y, you could just say it's 0. So these are your forces. Add them up. The x components plus each other, 2.8125 cosine 45. Let me put this in degrees. Plus the other y component, plus the other x component, minus 15. It's negative 13.0. So fx is going to be negative 13. And fy will be 2.8125 sine 45. Which is approximately 2. Okay, so how do you find the net force? Radical fx squared plus fy squared. Radical 13 squared plus 2 squared, which is 13.15 newtons. Let's check this. 13.6. Let me see, where did I go wrong? Okay, yeah, if this question in the course division is wrong, I just checked it now. It should be 13.2, not 13.6. So our answer is correct. If you round it to three significant figures, it's going to be 13.2. So just to recap, so you guys can get this. Anytime they want you to find resultant force, I know it's a lot of talking, but anytime you want to find resultant force, identify what the forces are. If they're opposite charges, then it's going to be attracting, so it's going to be pushing it away. If they're like charges, it's going to be pushing it away, repelling. Okay, so you know these are the forces. So it's very easy to find the resultant. Just find the resultant force, right? How do you find the resultant? You need to find each force and then split it into x and y components. To find each force, just do k, q1, q2 over r squared. That's it. And then split it into x and y components and you're done. Maybe here the only hard part was like to find the angle. Like I told you, you have 0.12, 0.12, then obviously the angle is 45 degrees. Okay. Question 13. An alpha particle has charge 3.2 times 10 to the negative 19. What is the electric force between two alpha particles that are a distance 1 millimeter from each other? You just apply, obviously, what is the force? You just apply the formula, kq1, q2 over r squared, right? If it's two alpha particles, that means they both have the same charge. They said between two alpha particles, so they have the same charge, right? So 3.2 times 10 to the negative 19 times 3.2 times 10 to the negative 19, because Q1, Q2, since they're the same charge, it's just square. Right? That's why they just put square. Okay, over the distance between them, since 1 millimeter, that means 1 times 10 to the power of negative 3, and then all squared. You get this. Okay, question 14. Find the magnitude of electric field at a field point 4 meters from a point charge Q equals 2 nanocoulombs. So the electric field has its own formula, and it's that the electric field is kq over r squared. Okay, similar to the force, kq and q2 over r squared is the same as kq over r squared. Okay, that's right here if you want to see it. So obviously to find the electric field here, same thing, kq over r squared. Very easy. So the charge. Okay, وكمان you have to remember انه you have to take the absolute value in this wait, do you? No, you don't. عادي. Just solve normal. Okay, kq over r squared, plug everything in, you're gonna get 1.13. Okay, and the unit is Newton per Coulomb. Okay, because you're dividing a. Okay, the unit comes from this. It also has a formula, F node over Q node. Okay, so Newton per Coulomb. This is another formula, but for some reason they don't use it here. I don't know why. But it's the other formula. So this is where the unit comes from. Okay, anyways, so this is how to solve 14. 15, consider an electric field due to a charge Q is equal to 16 nanocoulomb. Find the distance from Q where the electric field has a magnitude of 4 times 10 to the power 4 Newton per Coulomb. So same thing, you're just gonna do, remember, electric field is what? E is equal to kq over r squared. So we wanna find what r is. So r squared would just be kq over e. So k is 9 times 10 to the 9. E is what? As the q is what? 16 nanocoulombs. So 16 times 10 to the power of negative 9 over e, which is 4 times 10 to the power 4.
It's inside the house. I saw the
And you get r squared, so you just have to square root that. Let's take a look. So this, as we did, and then you have to square root it. So you get this value over here. At a point charge Q1 equals 6 nanocoulomb is, I'm recording something. Yeah. Nanocoulomb is located at the origin. What is the magnitude of the electric field vector at the point of coordinates minus 15, 20? So obviously you would want to find the distance between this and the origin. Okay, it's not hard to find distance because remember. Okay, so why am I finding distance? In case any you've lost, remember electric field is equal to kq over r squared. So we have k, it's a constant, q is given a charge, we just need to find the distance. They give us the point, so you can easily find the distance. Since you're starting at the origin, the distance will just be 15 squared plus 20 squared. Remember, the formula for distance is x2 minus x1 squared plus y2 minus y1 squared. Okay, but since x1 and y1 are both 0, you can just write it like this. Okay, anyways, so root 15 squared plus 20 squared, you get 25. Okay, so r is equal to 25. So kq over r squared will be k, 9 times 10 to the 9, times q, which is 6 times 10 to the minus 9, over r squared, so 25 squared. And you should get what you get. Oh, is this in centimeters? Oh yeah, it's in centimeters. Sorry, my fault. 0. I should have done. Oh, okay. I didn't see it was in centimeters. So I should make this point and point over here. So 0.25. So over here it should be 0.15 squared plus 0.2 squared equals 0.25. And then over here you have 0.25 squared. So let's take a look at the answer. Yeah, there you go. Okay, moving on, question 16. An electron of mass 9.11 times 10 to the minus 31 kilograms enters the region of a uniform electric field, as shown in the diagram below, with V node 2 times 10 to the 6 meter per second, and the electric field is 3 times 10 to the power of 2 Newton per Coulomb. The width of the plate is 0.25 meters. Calculate the speed of electron as it emerges from the electric field. Okay, so this question, sorry, it's a pain in the ass. I'm not gonna lie to you. but it's very important you know this because this comes every exam, came every exam last year. It will probably also come in your written part. So I'm gonna take this into open board and I'm gonna teach you the method, okay? So you need to understand that this motion, it's an electric field, so there are some forces acting on it and whatever, but the path of the electron that's moving will go like this. So this kind of looks like a projectile. So we're gonna solve for the y and we're gonna solve for the x because you guys know that at any point the velocity vector is tangent, so it looks like this. It has an x component and a y component. Okay, so we're gonna solve for x, we're gonna solve for y. After we find vx and vy, to find the final velocity we just do radical vx squared plus vy squared, right? So here is what we do. I'm gonna give you some formulas and I'm gonna try and get you to memorize them if you want to memorize them, whatever. So anyway, in the y direction, you need to know that it is UARM. Okay, there is an acceleration. Okay, and you should know that Vy is equal to acceleration times time plus v node y, the initial velocity of y, right? Type. You should know for x, it's a constant speed. Okay, so constant speed, and obviously x is equal to velocity times time, right? If it's URM. So let's work with y first. Let's see. Vy, our final y velocity, we don't know it, is equal to the acceleration, which we also don't know, plus the initial speed. The initial speed in the y direction is 0. Why is it 0, you may ask? You're telling me, Walid, oh, but it was projected at 2 times 10 to the 6 meter per second. Okay, I know, but look at the projection. The projection is completely horizontal. Okay, so your Vy is initially 0. And is it like that all the time? Yes, it always is. Okay, you're gonna see it. Every exercise is like this. It's never like this. Okay, anyways, it always starts horizontal. So Vy is equal to 80. I'm gonna give you a formula for A. I'm just gonna have you memorize it, okay? A is equal to F over M, right? F is equal to MA, so A is equal to F over M. In the case of an electric field, what is F? It's K, Q, sorry, it's F, Q node over F node, F node, hold up. Okay, yeah, if I had to check it. But in the case of an electric field, F is equal to EQ, okay, over M. Where did this come from? Remember I told you that there's a formula for the electric field. The formula we're using is KQ over R squared, right? But here, there's another formula, F node over Q node. So if you want to write F in an electric field, F is equal to EQ. So what does this mean? You're going to have F over M, so the acceleration will be EQ over M. And this is all given in the question, okay? What is the electric field? It's 3 times 10 to the power of 2. What's the charge? Q is charge. What's the charge of the object? It's not given. Okay, why is it not given? Because they told us it's an electron. Okay, you're supposed to, they expect you to have it memorized. You need to know that the charge of an electron is negative 1.6 times 10 to the power of negative 19 coulombs. If I'm not wrong, I need to check that. Is that correct? 1.6. Yeah, you need to have this memorized. Okay, have this memorized. You have to. Okay, times the charge negative 1.6 times 10 to the power of negative 19 over the mass of the electron, which is 9.11 times 10 to the power of negative 31. Okay, and you're gonna get, I don't know how much you get here, negative 5.27 times 10 to the power of 13. Hold up. Negative 5.27 times 10 to the power of negative 13. So this is our acceleration. So going back here, Vy is equal to 80. So Vy is equal to negative 5.27 times 10 to the power of negative 13 t. So we have a problem, is that we need to find t. We need to find the time to multiply Vy by. So there's nothing else we can really do here. We need to find the t. We know that we can find t over here. X is equal to Vt. So we know that the distance traveled is 0.25 meters, right? So 0.25 is equal to the velocity. The x velocity, we said it's a constant velocity. So it started with 2. So it's going to be 2 times 10 to the power of 6 t. So t is going to be equal to 1.75 times 10 to the power of negative 8. Is that correct? 1.25 times 10 to the power of negative 7. When you divide it, you get 1.25 times 10 to the power of negative 7 seconds. So now you found the time. You can go and plug it back in here. Vy is equal to negative 5.27 times 10 to the power of negative 13 times the time 1.25 times 10 to the minus 7. Okay, let's do it on our calculator. Or no, they did it here. You get negative 6.59 times 10 to the power of 6. Meter per second. Okay, so this is Vy. And we know Vx is always constant, which is 2. So obviously to find the total net, you do radical Vy squared plus Vx squared, so 6.59 times 10 to the 6 squared plus 2 squared. And you get, how much did they get? 6.89 times 10 to the power of 6 meter per second. So this is the final speed. In the solution, they also found the direction. Since they said speed, I don't know why you should find the direction, but let's find the direction. Always to find the direction of any vector, if you have the y component and x component, you know tan theta is equal to Vy over Vx. So just to find theta, you do tan inverse Vy over Vx. So Vy, which is negative 6.59 times 10 to the 6 over 2. So you do like they did here. They did it for you. You get, why did I put, no, wait. 2 times 10 to the power of 6. Why am I putting 2 now? The velocity here, how do I put 2 now? It's supposed to be, the velocity is 2 times 10 to the power of 6. I didn't read the 10 to the power of 6, sorry, huh? All square. So let's take it back into the calculator. You get 6.89 times 10 to the power of 6 meter per second. Okay, so to find theta, you do tan inverse Vy over Vx. So negative 6.59 times 10 to the power of 6 over 2 times 10 to the power of 6. And you're gonna get, as they got here, negative 73.1 degrees. So you can say that the particle emerges at 6.89 times 10 to the power of 6 meters per second, negative 73.1 degrees from the x-axis. Okay, so just to summarize, this is the solution. I proved all the formulas, and obviously, do you do this in the exam? No, definitely not. Okay, so what do you do in the exam? For a question like this, I'm gonna copy it again. Just so for a question like this, you remember to do these and follow these steps one by one. Okay, yellow for Vy, you want to find Vy and you find Vx. Okay, always remember Vy is equal to 80. Okay, are you gonna memorize this formula? No, you're not. Vy is equal to EQ over M times the time. Okay, this is what you should memorize. Okay, Vx, just remember the speed is constant. Okay, if the speed is constant, just what does that mean? X is equal to Vt. I think everybody has this formula memorized. Okay, so this is what I want you to remember. Remember that the acceleration is EQ over M times, and then obviously times the time later. Okay, to remember to find the time, plug in the horizontal distance into the URM equals. Okay, remember also, if it's an electron, they're not going to give you the charge. They're going to expect you to have it memorized. Okay, Q is equal to negative 1.6 times 10 to the power of negative 19 coulombs. Okay, and then obviously after you find Vy and Vx, you just remember V is equal to root Vx squared plus Vy squared. So I'm looking at the university physics book, and the example actually that's in the book, I know there's a lot of stuff. But the example that was given in the book is that they didn't give you the horizontal distance, they gave you the vertical distance in the book. And if he wants to get it, he could get it like that عادي يعني. So if he gave you the vertical distance, okay, if he gave you the vertical distance, this is if horizontal distance given. Okay, let's say over here, new question, same thing, but I'm just gonna write it like this. And over here, he gave you that the vertical distance is 0.25. Then what approach do you follow? If they gave you the horizontal distance, you follow this approach. Very simple. If he gave you the vertical distance, if he does, then follow this approach. You have to find Vy and Vx. Remember, for Vy, it's UARM. But are you going to use the equation Vy is equal to EQ over M times T? No, you will not, okay? You're going to use this equation. Vy is equal to root 2 EQ over M times Y. What is Y? Y is the distance traveled. Where does this come from? If you guys remember, V squared minus U squared is equal to 2ax, right? In this case, the initial velocity, the initial y velocity is 0, right? So V squared, the final velocity, is equal to 2 times the acceleration, which we figured out to be EQ over M in the previous part, times x, which is the distance traveled. In this case, we're going vertically, so we just call it y. And obviously, we just put the radical on the other side. So 2eq over m times y. Okay, so you can use this formula. Vy is equal to root 2eq over m times y. This is if, instead of horizontal distance, they give you vertical distance. Okay, and then Vx. Remember, Vx is always constant. Okay, so you can simply find the resultant by just doing Vy squared plus Vx squared. This is constant, so whatever the value they give you at the start, it's just going to be that for the whole time. Okay, maybe they give you vertical distance and then he asks you find the velocity and find when it leaves the field. Maybe he gets this. So in this case, you would want to find time. And would you be able to do x is equal to v times t? No, you would not. If they said find when it leaves the field, would you do x is equal to vt? No, because we don't have the horizontal distance. We only have the vertical distance. So it's not an option in this case to do that. Okay, in this case, to find the time, remember, Vy is equal to EQ over M T, right? So we know Vy. In this case, you would have found Vy, and you just equate everything, and you would find T. So let's write a small summary. This, we're going to call this case 1, horizontal distance given. Case 2 is if the vertical distance is given. Vertical distance given, we're going to call this Vy, we're going to call this Vx. If you have Vy, if the vertical distance given, Vy is equal to root 2eq y over m, okay, and Vx is always constant. Okay, then if they said to find the time, you substitute Vy is equal to EQ over M T. Substitute. طيب هيك بنكون خلصنا this question. I gave you both cases. Memorize them. Okay, memorize how to do it. Okay, we'll just follow it. Again, remember, if they ask for electron, the charge of electron, Q of electron is negative 1.6 times 10 to the power of negative 90. Okay, moving on. I spent too long on this. Question 17, determine the electric field at any point. The electric field at any point, we said it's okay. Yeah, this is a good question. They want the definition. So electric field E is the electric force experienced by any charge, right? Think about it. Enter, what is the electric field? It's the field where any point, any charge experiences a force, right? So it's the field where any charge experiences a force. So the electric field is the electric force experienced by any charge at the point divided by the charge Q naught. So they gave you the formula here, the one I was talking about earlier, which is F node over Q naught. Okay, so this is actually the formula, the second formula. But how do you know which one to use? Hasab what the question gave you. If they gave you force, then you have to use F over Q like we're doing here. But the questions we solved up, they didn't give you force, they gave you distance and they gave you charge. So you have to use KQ over R squared. So into hasab what they're asking for. Okay, you need to know. So another point, charge Q creates an electric field at a distance R from Q. Another point, charge Q is equal to 5 nanocoulomb acted upon by electric force 2 times 10 minus 3 due to the electric field created by Q. What is the magnitude of the electric field at the position of Q? So there's a lot of yap here. Just focus on what are they asking for. What is the magnitude of the electric field? How do you find electric field if they gave you the force and they give you the charge? It's very simple. F over Q. So you just divide. Very easy. Okay, question 18. What's the magnitude of electric field? 0.2 meters from a point charge Q equals 4. So see here, they didn't give you any force. Yeah, they didn't give you any force, but they gave you the charge or they gave you the distance. So which one do you use here? If you don't have any force, you have to say that the electric field using this equation, KQ over R squared. Okay, so remember Coulomb's constant K is 9 times 10 to the power of 9, 9 times 10 to the power of 9. And Q is given 4 times 10 to the power of negative 9. It's nano, so negative 9 over R squared. So 2 squared, and you get 9.0. Like this, thank you so much for watching, and good luck in your exam.